Okay, we're now recording. We're going to go over addition, subtraction, multiplication, and finally division for the same two polynomials, x squared plus 2x plus 3 and x plus 3. So to start with, I'm going to identify all like terms, by which I mean the same variable, like q versus r. Those are two different variables, would stand for two different things. Why else would you use two different letters in the same equation? In other words, we only have one variable in this case, which is x, but the difference is the other factor for consideration is the exponent. If we had q cubed and say q squared, that's not the same thing. Whereas if we had the same coefficient 3r, well, I had the coefficient 3r and 2r, well, the coefficient, that's the number thing that's multiplied by the letter thing. That's the number that's either being multiplied or divided by the variable. And in this case, even though 3 and 2 are different, that doesn't matter. The main thing is it's an r to the 1 power. R squared is not the same thing as r to the 1 power because r squared is r times r. And if you notice my inflection on R, that's because when one says the letter R, you've got to try and at least sound a little bit like a pirate. Or maybe a rodia or butter, like I had a Spanish professor tell me, like the commercials where I can't believe it's not butter. So you got to do something fun when you say R. And you also have to kill time while you're trying to erase with your Surface Pen on the Microsoft OneNote with the Microsoft Stencil Surface Pen on a Microsoft device. I don't get paid for product placement, but I wouldn't mind. Anyway, x squared doesn't have another like term because we're not combining like terms either because 2x and x squared are not the same thing. X over here isn't the same thing, and 3 and 3 is not a x squared kind of thing at all. If we had a 5x squared over here, for instance, then we would combine those, but it's not the case. So we have x squared, and I'm just going to put a blank underneath here and add the whole thing. And then, 2x, put an underline for that first one. And then we have x. Those are like terms. So plus 2x plus x. And then the 3, that's the constant. And that's another constant, same one, plus 3 plus 3. So x squared plus blank is x squared. 2x plus x is 3x, and then 3 plus 3 is 6. So we have x squared plus 3x plus 6. Now, what if we had the same polynomials? Poly means many, mono means one, binomial means two, trinomial means three, so that's a trinomial, that's a binomial. But they're both polynomials because there's more than one term. Yay, math vocabulary is fun. So we're going to now subtract them. So now it's x squared plus 2x plus 3 minus x plus 3. So in that event, we're going to distribute the negative. So that's really going to distribute the negative. That's -1 for all intents and purposes times x. And then the negative times positive 3, well, that's now -3. So now, really, we're just adding after having distributed the negative sign, or -1. So I have x squared, just like before. There's nothing like that. And then blank underneath. say minus so it's not confusing, but really we're adding them. So I'm going to put a plus after all. X squared plus 2x negative, that was, yep, minus x, and then plus 3, just like before. So then that's negative 3. Okay, well, x squared plus blank is still x squared. 2x minus x is plus 2x minus x plus x. And 3 minus 3 is 0. So we just have x squared plus x. So we've now done addition and subtraction. And now we can move on to multiplication. We could do the box method, or tabular method, but I'm going to do distribution. So if I have x squared plus, what is that, 2x plus 3 times x plus 3, that's our x squared plus 2x, yep, and then x plus 3. So then we have two terms here, so really I'm going to rewrite that as x times, because we're distributing that x to that 3, and then to that 2x, and then to that x. So x times, that's x squared times x squared plus 2x plus 3. And then we're going to add that to 3 times x squared plus 2x plus 3. So then that whole thing is going to equal, well, first x times x squared. That's really just x. X squared is x times x, and x is, well, just an x, so that's x times x times x, which could be rewritten as x cubed. And then x times 2x, so that's 2x squared. That's the same principle. That's a 1x. 1 times 2 is 2, and then x times x is x squared. And then x times 3 is 3x. And 3x is just 3 times x. All right, so now 3 times x squared is 3x squared. But I'm not going to put it underneath here because I want to have all my terms underneath each other, just like we did with addition and subtraction. That's right. There's a pattern here. There are patterns in math sometimes, pretty much always. Anyways, 3x squared, and then 3 times 2 is 6. So plus 6, and then that's just an x. And then 3 times 3 is 9. So that's a blank over there, blank over here. And incidentally, you could write this as 0. I like to use different colors for my invisible terms. So you could rewrite that as 0x cubed, and over here you could write that as really 0x to the 0 power, because 9 is really 9 times, 9 times x to the 0 power. Anything to the 0 power 0 to the x to the 0 power just equals 1. So if you had 9 times x to the 0 power, that'd just be 9 times 1. And anything to the 0 power equals 1 because of this thing called division. So say if we had x squared divided by x squared, well, that's really equal to, and x squared divided by x squared is just equal to 1. And you could imagine that rewritten as x times x divided by x times x, and the x's cancel out. So that's all you're really fundamentally doing when you take something to the 0 power. So it always equals 1, and anything divided by itself just equals 1, because that could also be equal to x divided by x times x divided by x, which again would just equal 1. Anyway, you want to use some kind of placeholder, or leave it blank, whatever. But you don't want to try and add 3x squared to x cubed. That would make things confusing, and math is confusing enough as it is, so let's not multiply that effect or add to it. Okay, so then back to blue. So then we have x cubed, because we add the coefficients, so that's 3 plus 0, 0. And we still have an x cubed. 2 plus 3 is 5. And then we keep the term x squared. And then 3x plus 6x is 9x. And then blank plus 9 is 9. So that would be our final answer. And then finally, we have the joy of division. I could also use the tabular method, but I'm going to stay consistent with the theme we're emphasizing here by using long division. So again, in this case, if I had x squared plus 2x plus 3 over x plus 3, well, the x plus 3 is the denominator. So I'm going to put x plus 3 on the outside, and then x squared plus 2x plus 3 on the inside. And then x times what is x squared? Well, x times x is x squared. And the trick is I'm going to put it, one of the tricks is put it over the second term, not the first term. So x times x is x squared. And then 3 times x is 3x. And then, and that's 3 times, so that'd be positive. But then we're going to end up switching signs, because I'm going to subtract this second set of terms from the first set. So that becomes x squared minus x. And then that becomes a negative 3 over here. So negative 3x. So 2x minus 3x is negative x. And then I'm going to carry down the positive 3 plus 3. And then x times what is negative x? Well, that would be negative 1. And then x times negative 1 is negative x. And then 3 times negative 1 is negative 3. Again, we're subtracting it, so we're distributing a negative sign, or negative 1. So then that becomes positive. And that also becomes positive. So that's, well, those two are going to cancel out. If you're not canceling out your first term when doing the long division of polynomials, then you're doing something wrong. And then 3 plus 3 is 6, but we already have a constant over here of negative 1. An integer, negative 1. What do we do with the 6? Well, also more to the point, is there anything we can multiply x by to get 6? No. So we have what's called a remainder. So this whole thing equals x minus 1 plus 6 over, so 6 divided by the original denominator of x plus 3. And that is the full answer, all 4 properties, and that is a wrap.